Hi again. So today we're going to talk about reciprocal trig functions. Again, keep in mind that math is consistent. We already know a lot about reciprocals. You essentially have three kind of new vocabulary words to learn, and then all of the math will come along easily from there. So here we go. You got an Inspire document in class today to go along with today's video. I know you haven't done that in a while. You may also want some scrap paper to go along with it. It's entirely up to you. I'm just going to talk you through some parts, and then I will go to the document and be writing as well. So here we go. Open up that Unit 6, Day 8, Reciprocal Trig Functions document. Let's go right to page 1, 2. This does have different sections. We're going to always, of course, start with a must-do. Okay, well, you know what a reciprocal is. A reciprocal, not technically, is a flipped fraction. It's when you take, it's a number that when you multiply it, when you take a number and you multiply it by its reciprocal, you always get 1, the multiplicative inverse. So, for these examples, I say let's write the reciprocal of each of the following, or we could just talk through them. So, 2/3, the reciprocal, flip that fraction, is 3/2. -7/4, when you flip that fraction, is -4/7. Notice the sign stays because, again, when you multiply a number and its reciprocal, you want to get a positive one. -5, well, you could write that as -5/1, so its reciprocal would be -1/5. For number 4, the reciprocal of 1/6 is 6. For number 5, think about number 5, it's interesting, and this comes up a lot with trig. You could write 0 as 0/1, and when you flip that, you get 1/0, which is undefined. So for the first time, we can talk about 0 having a reciprocal, and in fact, the reciprocal of 0 is undefined. Likewise, because math is consistent, the reciprocal of 1/0, or undefined, is 0/1, or 0. So the reciprocal of 0 is undefined, the reciprocal of undefined is 0. All right, moving on to page 1-4. Like every number, every trig function has a reciprocal also. Here are their names, and this is the new part, is understanding and remembering and learning and studying the names. So the reciprocal of the sine function is cosecant. The reciprocal of the cosine function is secant. And the reciprocal of the tangent function is cotangent. Okay, page 1-5. You need to know the abbreviations for those functions too. Cosecant is CSC, secant is SEC, cotangent is COT. Okay, just like sine is SIN, cosine is COS, and so on. Page 1-6. Finding the values of reciprocal trig functions. So to find the values of reciprocal trig functions, you simply use what you know and then flip it. So again, here's another example of why it's so important that you're getting to know your unit circle values really well, because the less you have to think about the sine of 30 being 1/2, the less time it'll take you to figure out that the cosecant of 30, its reciprocal, is 2. Okay, so if you know your unit circle real well, it won't take you so long to flip those values. Okay, 1-7. So here's how it works. We're going to evaluate these 5 functions. At this point, we will go to the document camera and move on from there so you can actually see the thought process in writing all of this out. All right, so now let's go through and talk about exactly how to find those reciprocal trig values. So here I have, that's better, the cosecant of 30. So things you want to think about. Well, the first thing is, what's its reciprocal? And I want you to write all this and show the work every time. So cosecant of 30 is the reciprocal, you can say recip, of the sine of 30. Well, the sine of 30 we know is 1/2. So I'm looking for the reciprocal of 1/2. And the reciprocal of 1/2 is 2. So the cosecant of 30 is 2. All right, let's grab our next one. Okay, so here we go. Number 2, the secant of 135 degrees. Well, secant is the reciprocal of cosine. So I'm looking for the reciprocal of the cosine of 135 degrees. Well, I've learned that the cosine of 135 is negative square root 2 over 2. Looking for the reciprocal of negative square root 2 over 2. So I need to flip negative root 2 over 2, and I get negative 2 over root 2. That will be a fine answer in pre-calculus. It is not a fine answer in Regents Algebra 2 Trig. We need to get rid of square roots in the denominators. So I multiply by that square root, and what I do to the bottom, I must do to the top. Simplify. So I have negative 2 root 2 over root 2 times root 2 is 2. Those 2's cancel, and I'm left with negative square root of 2. So the value of secant 135 is negative square root of 2. Again, notice it's going to be a little bit of work, so you want to make sure you know your unit circle very well so that you can spend your time on the new work, not on the old stuff that you should know by now. Okay, a couple more. Cotan 240. Well, cotangent is the reciprocal of tangent. So if I know tan 240, well, tan 240 is a child of 60, so that's root 3. And 240 is down here, and that's a positive slope, so it's positive root 3. So I need the reciprocal of root 3. Well, the reciprocal of root 3 is 1 over root 3. Once again, I need to clean that up. You may recognize this, though. When I take and multiply both parts by the root 3 over 3, I get root 3 over 3. I said the answer. So with tan, while we say that tan can be trouble, with the reciprocal functions it's not. The reciprocal of root 3 is root 3 over 3. And I bet you can guess what the reciprocal of root 3 over 3 is. Root 3. So let's take a little less work, which is somewhat shocking with tangent. Okay, so we can also start with radians. We have secant of 7 pi 6. Well, secant is the reciprocal of cosine. So I'm looking for the reciprocal of the cosine of 7 pi 6. Pi 6 is a 30. So my answer, cosine 30, is root 3 over 2. But it's 7 30s. 7 times 3 is 210. So it's the cosine of 210. Quadrant 3, cosine is negative, so I need the reciprocal of negative root 3 over 2. So now I take negative root 3 over 2 and flip it, so I have negative 2 over root 3. Again, no square roots in the bottoms of fractions. Multiply both parts by root 3, and we get negative 2 root 3 over 3. The secant of 7 pi 6 is negative 2 root 3 over 3. Okay. Cotangent of pi. Well, that's going to be the reciprocal of the tangent of pi. Pi is 180. So I'm looking for the reciprocal of the tan of 180. Well, tan of 180, that's slope 0. The reciprocal of 0 is undefined. Cotan of pi is undefined. And that's really all there is to it. If you know your unit circle values well, flip them, clean them up, and boom, you're done. So we're going to continue building on what we've learned with our unit circle, and every day add one more little step. So keep studying your unit circle. If you don't know your unit circle well yet, now is the time. All right, so let's pause for a minute before we go to the should-dos. Okay, for the second part of this, the should-do section, you also need to be able to simplify complicated-looking expressions into expressions that only have sine and cosine in them. So on page 2.2, please understand that any trig function can be written in terms of sine, cosine, or both. You just need to know your reciprocals and your basic algebra. So, keeping in mind, review from what you learned earlier, sine is the reciprocal of cosecant, so cosecant is 1 over sine. The reciprocal of cosine is secant, so secant is 1 over cosine. And the reciprocal of tangent is cotangent, so cotangent is 1 over tangent. Or, tangent's always got more going on. Remember, tan is also sine over cosine, so if I need to take its reciprocal, you flip it, and we could also say that cotangent is cosine over sine. All right. So So on page 2.4, we're going to take, these are just instructions, some more expressions and simplify them. And again on 2.5, there are 4 examples, and we'll go through that on paper with a document camera. Okay, so when you're asked to rewrite things in terms of sine and cosine, you do exactly that. You make substitutions. So cosecant is the reciprocal of sine. I call that 1 over sine. And tangent we know is sine over cosine. So I rewrite them, and then I do my algebra. So I have a sign on top of a fraction and a sign on the bottom of a fraction that I'm multiplying. I can cancel them, multiply straight across, and I end up with 1 over cosine theta. You're done. So again, it's nothing you've never done before. It just looks different because we have sines and cosines instead of a's, b's, and c's. Okay, so in number 2, I'm going to rename cotangent as cosine over sine. Cosecant is the reciprocal of sine, so I'll write it as 1 over sine. And then there's nothing I can reduce, so I multiply straight across. Cosine times 1 is cosine theta. Sine theta times sine theta is sine squared theta. You could write that as sine theta squared, but the practice is to put the squared between the trig name and the angle name. Okay, so here I have a fraction. I'm going to rename it as division first to help me out later on. So I rewrite that as cosecant divided by cotangent, and then I write them in terms of sine and cosine. So cosecant is the reciprocal of sine. I write it as 1 over sine. Cotangent is cosine over sine. Division, you multiply by the reciprocal of the second fraction. So I have 1 over sine times sine over cosine. And again, now we're multiplying, so I can cancel like things top to bottom, multiply straight across, and I end up with 1 over cosine theta. Okay, so there's one more to do. You can try it on your own and pause or listen through. Cosecant theta divided by secant theta is 1 over sine theta divided by 1 over cosine theta. Division again, multiply by the reciprocal of the second fraction. So 1 over sine theta times cosine theta over 1, and multiply your fractions straight across. 1 times cosine is cosine theta, sine theta times 1 is sine theta. And that is it. See you tomorrow.